Okay, so looking around on CodeWars, I went into practice and sorted by popularity, just because I was curious, what's the most popular CodeWars challenge? And it came up with this multiples of 3 and 5 challenge, which looks like something I could create a video on, because it's quite interesting. So if I just summarize the problem, if taking this example, if we list all of the numbers below 10 that are multiples of 3 and 5, we get 3, 5, 6, and 9. And then the sum of all those multiples is 23. 3 plus 5 plus 6 plus 9. So finish a solution so that it returns the sum of all the multiples of 3 and 5 below the number passed in. And it provides an edge case here. If it's negative, return 0. Fair enough. And if the number is both a multiple of 3 and 5, then we only count it once. So naturally, the initial thought would be to just loop over all of the numbers and, check if it's a multiple of 3 or 5, or maybe both, and add that to a list. But as you grow in the size of the number that you're processing, you're then doing a lot of unnecessary checking. So my initial kind of thought was that this is likely to be something that can be calculated. And when I tried to think about how you'd calculate the answer, I started to think along the lines of triangle numbers. So if you're not familiar with triangle numbers, the triangle number sequence is the sum of the numbers up to a particular value. So it would be 1. So if I just list, just numbers, and the triangle numbers would then be 1, 3, which is the sum of 1 and 2. And then you've got 6, which is the sum up to here. Then you've got 10, which is the sum up to here. 15. So you see, the sequence. And the reason the reason it's called triangle numbers is because if you list out these numbers as ones, you can just have a stack of ones. 1, 1, 1, 1, 1, 1, 1, and then 1, 1, 1, 1, 1. You can see it forms a triangle shape. And of course, if we take the sum of all those ones, there's 15 of them, which is the 5th triangle number. Now, you can calculate triangle numbers because they are very similar to a square. If you imagine that you duplicated this triangle, and if you go up a row, you could actually copy this entire set of ones, rotate it 180 degrees, and it would create a rectangle of length base 5 and height 5 plus 1. So you can actually calculate the nth triangle number by taking n and multiplying it by n plus 1 and dividing the whole thing by 2. So we can actually do that. So if I go 1, 2, 3, 4, 5 and say that is n, and we do equals n times n plus 1. Of course, we need that in brackets for the order of operations. And then divide by 2. We get 1. Drag that across. We get the triangle number sequence. Brilliant. So, what's that got to do with this problem? Now imagine instead of 1s, we had 3s. Let's scroll down a bit. I'll just do the first few because you get the concept. So here, what we're actually doing is we're writing out the multiples of 3, which is exactly what we need in our problem. So I think the base problem of this challenge is rooted in manipulation of triangle numbers. And I think looking at here, you've actually got, so 3 would be the triangle number. 6 would be the triangle number. If we do sum of all of this, we've actually got, taking this third term in the sequence of triangle numbers, here we've got the same third term, but multiplied by 3. And you can see why that would be the case, because each of the ones is simply multiplied by 3. So I think we've got a plan of attack for the algorithm, which is going to be a mathematical calculated version. Rather than doing any kind of looping and wasting energy with that, we can actually calculate the relevant triangle numbers and solve it that way. So with that, let's get coding. So the first thing I think we're going to need to do is calculate the highest multiple that is below the number that was passed in for both 3 and 5. So const highest multiple of 3 equals, well, let's think about this. You take the number divided by 3. But the problem with that is if you had 3, for example, the highest multiple would be 3, but we want it to be below that number. So we actually have to always do -1 and take the multiple there. Oops, put that in the wrong place. So if we passed in 6, for example, we wouldn't want to include 6 because it's not below the number. So in that example, we would take 6 -1, 5 divided by 3 would be something like 1.666 or something. Then we'd want to do math.floor to round that 1.66 down to just 1. So 1 would be the divisor, if that's not clear. So we can then use this highest multiple to get, really that's the highest number in the triangle number sequence, actually, or actually it's its index in the series of the 3 times table. So let's just take 12 instead. 12 -1 would be 11. 11 divided by 3 would be something like 3.666, I think. 11 divided by 3. 3.666. And then we would take the floor of that, so 3. So essentially, 3 times 3 is 9. So we've taken we've basically got the third item in the 3 times table. So 3 represents that. So that's good. So if we've got that index value of 3, we now need to translate that into its triangle number, I think. Yeah, that would work, I think. So let's implement a triangle number function. So going back to our example here, so we've just done, like, say we had as our input 12. We took 12, we deducted 1 to get 11. So then we divided by 3, and this is to calculate basically either 1, 2, 3. We're calculating this value here, so 3, because 3 times 3 equals 9. And what we then need to do is, based on this index value here, not index, it's the multiple of 3, really. It's the nth term in the 3 times table. So based on that nth term, we need to get this 18 value. So that's the sum of all of the terms of the 3 times table, which is based on the triangle number. So we need to get the third triangle number and then multiply that by 3. So that's what we're going to do. So we're going to get triangle of the, that should be renamed to nth term in 3 times table. There you go. That's at least clear. Nth term in 3 times table. So yeah, because that is 3, which is the nth term. So we're going to do the nth term in the triangle series, which is going to return 6, I believe, because it's 1, 3, 6. That's the, based on this here, 6. And then we're going to multiply that by 3. Because we need to translate the 6 into 18. So that's cool. And this basically is the exact same thing we need to do for 5 as well. So if rather than repeating it, let's put it in a function. I don't quite know what to call it yet. Term or something, I don't know. Number. Yeah, so we're going to go, we'll call it divisor. No, we'll put, yeah, divisor. And we'll do, because it is basically the divisor, isn't it? 3. Sorry that goes off the screen, but maybe zoom out 1 notch. There you go. And then we'll return sum of 3, which is no longer 3, it's n. Let's go n. Nth term in, using n twice, but you get it. And we'll return sum of n. In fact, we don't need that variable, so let's just return that. And let's give that a better name. Well, it's sum of multiples. Sum of multiples, and we'll do sum of 3 equals sum of multiples 3. Actually, it would be number. Yeah, we need the number in there as well, don't we? Number. And we'll pass in 3. And then sum of 5. Now, this is where we could get caught out. And I kind of thought ahead. Because we don't want to double count things that are a divisor of both 3 and 5. But we've got this function. And I think it's correct to state that if it is both a multiple of 3 and 5, then we're going to be double counting. Okay. So we need to reduce the double counting by just one occurrence of that double counting. And I think it's correct to state that the triangle number sequence of 15 is always going to be the values that double count 3s and 5s. Therefore, I think we could do this sum of 15 and then deduct this from the final result. So we could do sum of 3 plus sum of 5 minus the sum of 15. And I think that gives us our answer. So let's test it. Find all the bugs that I've written. Okay. Triangle is not defined. Apparently I can't type triangle. Okay. Okay, nth term. Okay, again, I've done something stupid here. Nth term in 3 times table. Yeah, I've renamed that and didn't rename that. Awesome. Well, it passes the basic test. Let's do an attempt then, I guess. Ooh, we've got some failures. Juicy. What have I? Okay, I haven't accounted for one of the exceptions, which is if number is less than or equal to 0, because the answer would be 0. Return 0. Let's attempt again. And they all passed. Nice. So I'm curious to see how others have done this. But the beauty of this solution is we're not doing any looping. It's just pure calculation. And yeah, that means it's kind of it's more efficient than even linear time. It doesn't scale linearly. It's pretty instant. So yeah, I'm happy with that. I'm going to submit that and have a quick look at some of the other solutions. You could probably compress it down to like a one-liner or something. But I'm not going to do that right now. Let's see. We've got. Yeah, so here we go. Here's the top solution, which is doing the very thing I kind of wanted to avoid, which is iterating over pretty much everything. Oh, you're doing I++ as well. I suppose, yeah, you kind of have to. Feels like there could be a more efficient way, even with a looping solution, to come up with it so that you don't have to iterate every single number. There we go. But yeah, this is a way to do it, and probably the most logical or the most immediate solution that comes to mind. But yeah, it's less efficient. Anyone else doing the triangle number solution? Wow, really not. I must admit, I'm quite surprised. Everyone's looping. Oh, well, there you go. It's quite innovative then, apparently. Ah, here we go. Yeah. Yeah, this is using the triangle number solution, I think. Yeah, this is basically doing what I did. Yeah, so, okay, trunk. I've not used trunk. I assume it's some kind of floor thing. Cool. But there we go then. I'll leave it there. So yeah, I really want to hear from you guys. My main focus, I think, at this point in my career is that I want to provide as much value as possible to as many people as possible. So I'm willing to help. If there are any challenges you particularly want me to look at, just comment and request it. I'll be reviewing them. Yeah, please subscribe and support the channel. And yeah, look forward to my next video. Thank you very much.